As we've discussed before, when passing parameters to a function, the formal parameters are assigned the values of the corresponding actual parameters. Since immutable values cannot have their values changed, when passing an immutable object, the corresponding actual parameter cannot be changed. In this example, the main1 function has a variable named x that is 2. Let's debug it. We've paused at the breakpoint on line 7. We'll step into the square function, and it assigned the square function's x parameter to hold the value of the main function's x. Remember, these are two separate variables named x. I've drawn a diagram to show this. We evaluate x times x and get 4, and then reassign the square function's x to hold the new value. That does not affect the 2 or the main function's x. We did assign the square function's x to hold that result, so it now refers to the 4 as the updated diagram shows. We'll return to the main1 function and output x and y. We can see that the main1's x is still 2 and y is 4. We'll press resume and it pauses at the breakpoint at line 11 in the main2 function. It should be more obvious that reassigning a formal parameter does not change the corresponding actual parameter if we pass a constant value as the parameter. There is no variable in the main2 function that can store a different value. When we step into the square function again, we can see that x is assigned the value 2 as the diagram shows. When we step out, y is 4 and we output that. Even if we pass a mutable type such as a list or a point to a function and reassign the parameter variables inside the function, the corresponding actual parameters do not change. We'll debug this program and stop at the breakpoint at line 12. As we can see in the diagram, the main function has two variables, a point and a list. When we step into the function f, we see that formal parameters are assigned the corresponding actual parameters. The updated diagram shows the representation of Python's memory at this point in the execution. We'll now step over twice and reassign each formal parameter. As before, this does not change the corresponding actual parameters. This causes a new point and a new list to be created. The updated diagram shows the picture of Python's memory. We can also use the frames view to see the updated values of point and items in the function f are no longer the same as the values of p and items in the main function. When we print out pt and items, we of course see the updated values. And then when we step out of the function and go back to the main function, p and items are still their original values and we output them. This example shows that when you pass a mutable object and mutate it, instead of reassigning it, the actual parameters are changed. This is because both the formal parameter and actual parameter point to the same object that is being mutated. Let's debug it. We create a point and a list as before in the main function and have the same picture of memory as before. We'll step into the function and we also have the same picture of memory as before with the formal parameters and actual parameters pointing to the same objects. But this time, instead of reassigning the pt variable, we called the move method that mutates the object. And instead of reassigning the list items, we mutated the list by reassigning what is stored at each index in the list. We are not reassigning the list items to a new list. It still refers to the same list. We are mutating the list to hold different values. The updated memory diagram shows that we still will only have one point object and one list, but they now have been mutated. The frames view shows that pt and items in the function f have the same values as p and items in the main function. Since the variables point to the same objects, this must be the case. We see the updated values when we print them in the function f, and then when we step out of the function, we also see the same value in the main function. In Python, the only time an actual parameter can be changed by a function is when you pass a mutable object and the function mutates it. In all other cases, a function will not change the corresponding actual parameters.